Hi, I'm Taylor Southwick, and this is my progress update for MEMS 5001 optimization. So, recap, my project is to optimize the cross-sectional design of a monocoque for WashU's Formula SAE race team. To do this, I am looking at the geometry of the car where the front rockers connect, which is where the forces are highest on the frame. And I am also looking at the carbon fiber layups of the frame at those points. So behind me is a bit of a diagram of what my design roughly looks like. It's a trapezoid shape right now with two known forces being applied and two reaction forces. And with that, I can calculate the stresses, the strains, and most importantly here, the torsional stiffness of that shape so that I can find out how stiff the frame will be, since my main design variables are minimizing the weight while maintaining a certain torsional stiffness. The other element of it, besides just that shape, is the laminate, which is layered with a balanced symmetric laminate on all sides. The complicated part here is that each side does not have to have the same laminate. And because that is the case, it allows for a lot more space for optimization, since you can have different length and different width laminates and different orientations for your layup at different points, depending on the specific forces at those points. So right now, my design is fairly simple. My code is fairly simple. It is just looking at the forces on that shape, just trapezoid with the bottom length set firmly, and the top height can change and the width of the top bar can change, but it's still going to be symmetrical. And the forces will simply move in plane with where they are as the sides change. And that is a reasonable approximation, since the rockers would have to move with the frame moving anyway, but they would stay in the same place directionally with the forces that they apply. The biggest problems that I've had so far have been calculating the frame's torsional stiffness accurately. I don't really want to make aggressive approximations with the corners, but as of right now, I'm making pretty broad ones that they are simply a pin connection. And I'm not concerning myself with failure there. In actuality, they will actually be the thickest part. So that is not a terrible assumption. It's more likely to have failure either from buckling in the top or bottom or from shear where the rockers connect. So I'm looking mostly at those places. For the layups, my biggest problem so far has been in order to get a balanced layup, the sum of the angles of all the layups has to be some multiple of 90 degrees, which means I'm using MATLAB's mod function to find out if you divide it by 90, do you get a remainder of 0, which works for 0, 90, and all of its multiples. The issue with this is that it's no longer a linear constraint, which complicates my design space a little bit. It would be convenient if I knew it was going to definitely be 0 or definitely be 90 or definitely be 180 or something. But for now, I've been working with that, and it's a nonlinear constraint, but it still will be effective. As far as how I'm doing in terms of progress, the whole design process is laid out quite well. The only thing that I have scaled back for now is the shape there. I'm only looking at a trapezoid right now. I was originally going to look at any design shape made up of straight lines between any number of nodes, as long as they don't cross through the center, since that's where the driver has to sit. So it could have been a hexagon or a pentagon with varying lengths on different sides. I'm not doing that currently. When I'm nearing completion, if I have extra time, if I haven't overworked the project too much, I will add that level, which I think will be relatively easy to do later down the line. But for now, the way that I have it set up will simplify the design just to make sure that it is going to be able to give me useful results before I try to add that next level of complication. My solution style has, I'm planning on doing FMINCON. I have all the constraints set up already. I just haven't actually run that yet. I might do a genetic algorithm if the geometry isn't cooperating, since it's not really a linear relationship. And the genetic algorithm may be able to get to the more dynamically involved systems better. But for now, I am sticking with FMINCON. The only other issue that I have is defining the number of laminate layers. I want it to be a floating variable that can change to any value it sees fit. But in order to do that, I have to allow for any number of variables, and 0 is a valid answer for a layup orientation. So I've had a little bit of trouble setting that as a free variable and orchestrating it correctly, and not just leaving them blank, or having the program not simply leave them blank, which would be the ideal choice there for me, at least. So as of right now, I've just been defining it as there are 4 angles, or there are 6 angles, or whatever. Run, let's see what happens, let's see what we can do. And hopefully I'll be able to resolve that, but if not, then I'll just keep it to some even number of layup angles and get a good approximation there, and then perhaps rerun it at a different number and see how we do. And that is everything I have. I think I should be on track for completing, and everything going well should work out. Thank you.